Now, suppose someone said, hey, I want you to evaluate exactly some really complicated expression with just sines and cosines or tangents or whatever. And, for example, suppose someone said, I want to know the exact value of this. Let's take a look at sine of pi over 9 radians times cosine of 7 pi over 18 radians plus the sine of 7 pi over 18 radians times the cosine of pi over 9 radians. Hey, well, now what are you going to say? You're going to say, well, gee, pi over 9 radians, that's not a standard one. I don't even know what that is in degrees. 7 pi over 18, I have no idea what this is. So there's no hope. There's no hope. But suppose a person put a gun to your head and said, I want the answer and I want it now. Well, now you're even more nervous because it's a gun to your head, you may be killed, it's sort of awful, it's really, really tense moment. But then, in a moment of inspiration, you suddenly look at this and say, hey, wait a minute. I see a sine and then a cosine plus, and the sine of the other angle times the cosine of the first angle. That actually looks like the formula for the sum of angles with a sine in front, the sine of a sum. So actually, this is the answer to the question, what is the sine of the sum? Pi over 9 plus 7 pi over 18. Let's just check, because what does sine do to a sum? Well, remember, sine is friendly, so it shares the wealth, so you get sine of this times cosine of that, and sine is a friendly thing, so plus, plus, and then switch the roles. So now we have the sine of this person times the cosine of that person. That's exactly the same thing. These are the exact same thing. Well, what is that sum? Well, that's sine of, well, pi over 9 is the same thing as 2 pi over 18, and 2 pi over 18 plus 7 pi over 18 is what? Well, it's 9 pi over 18. But 9 pi over 18 is the same thing as pi over 2. And what's the sine of pi over 2? Well, that one we know. You could think of the graph or just know that, in fact, sine of pi over 2 is 1. Sine pi over 2 is 1. So this horrendous thing turns out just to be 1. Even though I don't know the value for any one of the individual things, I know when you put it up in this combination, since it equals this, it equals 1. So sometimes when you see something really complicated like this, you may be able to sort of condensify it into just one trig function of a sum or a difference, looking at this formula and detecting what it would be. Let me try one more example to sort of drive this home. How about if someone says to you, find the value of tangent 47 degrees minus the tangent of 2 degrees divided by 1 plus the tangent of 47 degrees times the tangent of 2 degrees. Well, of course, this may appear hopeless at first, but then you immediately say, gee, that looks like something to do with the tangent of either a sum or a difference of angles. Since that's a negative sign, this must be the difference of angles. So immediately, without even sweating, you're going to report, well, wait a minute, that's exactly the tangent of 47 degrees minus 2 degrees. Because remember, the formula for the tangent of a difference is the tangent of one minus the tangent of the second divided by 1, and then you switch the sign, so plus the product of the tangents. So what is that? Well, that's just tangent of 45 degrees. And what's the tangent of 45 degrees? Well, remember, it's just sine of 45 degrees over cosine of 45 degrees. The sine of 45 degrees is the square root of 2 over 2. The cosine of 45 degrees is the square root of 2 over 2. So the square root of 2 over 2 divided by itself is 1. So in fact, the tangent of 45 degrees is 1. So this complicated expression turns out to exactly equal 1. Even though I don't know the value of tangent of 47 degrees or the value of tangent of 2 degrees, I know exactly what this combination of them is. So that's sort of interesting. In this really complicated expression, it turns out to equal 1. In this really complicated expression, it turns out to be 1. So therefore, if anyone ever gives you a really complicated expression with trig, the answer must be 1. Well, not quite. But anyway, try these and see if you can figure out which one is 1 and which one isn't 1. See you soon.